Hi, welcome again. We're gonna continue what we were doing last time. So we're going to again we're gonna read off how these blocks are defined. Now, of course, if you look at OpenFOAM.com, the tutorial guide, this will show you actually how it's being done. The OpenFOAM how to blockMeshDict. Now if you look here, this will tell you how to write your coordinates, but it may be a bit scary again if you want to read through all this, but don't worry, we're here to look at how it's being done in OpenFOAM. Okay, so let's begin. Remember, the blocks here are named 0 all the way up. It starts from 0, and as you can see, okay, I'm going to quit this. blockMeshDict. Yeah, as you can see, if you label your vertices as such, this will be the first one here will be the 0 point, then you point 1, you have point 1, point 2, point 3, point 4, and so on all the way up. So that's how we are going to name our points. Alright, so if you see this hex, this means there's a block. There's some kind of a block. It says 0, 1, 3, then 2. It's actually referring to 1, 3, okay, 0, 1, 3, then 2. That's how it's being done. As I was discussing before, there is a specific way in which you must define your blocks. Okay, there's a specific way you're supposed to define your blocks, and we're going to look at how the tutorial file actually does it. Okay, let me finish the labeling here. Of course, we could have done this in Excel, but no matter. These are 15 points here. So let's look at the hex. Let's look at the hex thing first. Well, the blocks. Okay. Don't worry about this. This actually means how many meshes in each direction. So we don't. Yeah, it's going to tell us how many boxes there are in the particular block. We don't need to really care about that for now. We already know how that works because, well, that's what was explained in the fight when we tried to make our mesh resolution even better. So, okay, we move on. So the first thing we need to know, okay, it starts from 0. So where does it start? Where is it? 0, 0, 0 on this plot. So we'll look for x equals 0. Okay, can you see? If we hover over these points, this will show us where the 0 point is. Okay, so I'll try and zoom out a bit. Okay, I'll pan this up here. We have the rotation function. Okay, so we'll try to find something that is easy for us to try and move on to paint. Okay. Now that's the thing about free tools, yeah? Free tools are sometimes a little difficult to see. Let's reorientate until we find something more comfortable, then we can copy and paste it over. Okay. So again, there is 0, 0, 0 right over there. Okay, right at the end. So I'm gonna copy this picture over. On to paint. Okay, so I'm going to delete all of this. this is our picture. If you want to see what the geometry is like, of course you'll draw some lines here to help you see where the box is, so to speak. Okay, that's one side. So you're moving to another face. 1, 2, 3. Okay, draw it to the back. Alright, and then the back side. Okay, I'm going to use a lighter color to denote points that are behind where it's very hard to see. So 1, 2, 3, and of course 4. Hopefully you can see where the geometry is now. So we have two comparisons side by side. This is our what our file looks like. Of course, if you don't want the gray bits, that will do just as well. Whichever is easier for us to see. Okay. Close this up. Okay. So now we'll have to carry on the task of naming the points. Alright, so again we're gonna copy a clean what do you call it, a clean 3D plot. And where is 0, 0, 0? 0, 0, 0 is here. So that's point 0. Where is point 1? Okay, 0, 1. So there's a 0.6 is here. Can you see this point? So 0 is here. 0.6 is here. 3 is here. Where is 3? Yeah. 3 is this one. And this is number 2. So this is point 0. This is point 1. Okay. 0 is point over here. 0, 0, 0. That's here. 0.6, 0, 0 is here. 0.40. That is here. That's number 2. And this is number 3. Okay, so you can see the direction. 1, 2, 3, and 4. Otherwise it's point 0, 1, 3, 2. Can you see? 0, 1, 3, 2. Okay. So we're going to record that down in our paint. Alright, so use the brush. There we go. 0. Let's use a red color. 0, 1, 3, 2. And you can see it's actually sort of giving you the bottom face. Okay, so first block. You'll be like so. And actually the second block will have a very similar kind of a pattern. 1, 2, 3, 4. Okay. 1, 2, 3, 4. Alright. So let's see whether it's the same. So we're gonna check 8, 9, 11, and 10. So where's point 8? Let's find point 8. Point 8 is here. 0, 0, 0, 0.1. Let's find point 9. Point 9 is here. 0 0.6, 0 and 1. 0 0.1. Point 10 is here. 0 0.6, 0 0.4, 0 0.1. this point 11, sorry, this point 11, and this is point 10, 0, 0 0.4, 0 0.1. Okay, 8, 9, 11, 10. Point 8, point 9, point 11, point 10. So 8, 9, 11, 10. So you can see there's a very specific way it's being described. So which block is this talking about? Well, if let's say, okay, it's a bit hard to see here, okay, but anyway, this is how it's done. So we're going to draw like so, orange being the first circle, so to speak, or the first face is at the bottom, and then we'll use red as the second part. Can you see there are 8 points being selected? The block at the back is the block being defined. So what is the pattern here? Okay, what is the pattern here? You can see, of course, there's a block here. Well, the pattern is that we start at the origin, so-called, or the point closest to the origin, which is in this case the origin itself. We go in the x direction, we increase the x direction, then we increase the y direction, then we go back in the x direction. So increase x, increase y, subtract x. Alright. So to define block, we go in we start at the origin. So that's the first step. So there are 8 steps here. We start at the origin, we add x, increase x, we add y, then we subtract x. So number 5, point 5 is over here at the top. So from the origin, we add z, we add the block in the z direction, then again add x, add y, subtract x. So we're going to copy these 3 steps and put it here. So that's how we define our 8 points. So that's how we define one block. Okay, so this is that true guide, of course, in the OpenFOAM. What they tell you is this. Now, this is how it's supposed to be defined for each block. So the axis origin is the first entry. So let's say it's this point here, point 0. Then we go in the x1 direction. If we go from 0 to 1, that must define the x direction, x1 direction, or in this case it's just x. So 0 to 1 is this way. Then we add the y direction, which is in this place is called x2. So 1 to 2, that increases the y. Then after that, we decrease y, so we complete our definition of the bottom plane. So 1, 2, 3, 4, or 0, 1, 2, 3. That's the bottom plane. So we look at the 4th or the 5th point of vertex 4 in this case. We add z, 1 here. Then we add x, we add y, then we subtract x. For all the blocks, it's very standard. So can we kind of guess what our next block, how should we name our next block? Well, if we go back to this, we can see that this is the point closest to the origin. So we add x, we add y, we subtract x, and then we go to this point here. So this bottom 4 points will form our bottom plate, these top 4. So we add z first, add x, add y, subtract x. That's it. So what should our point look like? So this one, 0, or rather, yeah, let's just look at what it's being prescribed for us. So 2, 3, 6, 5. Okay, I'm gonna bet you it's gonna be those few points. 2, this one, 3, this one, number 6. Number 6 is down here. Number 6, this one, number 5, this one. Okay, and then what's the next 4 numbers? 10, 11, 14, 13. Okay, so 10, 11, 14 and 13. 10 is here. Yep. 11, so 0, 0 0.4, 0 0.1, 11 is here. 10, 11, 14, 13. 14 here, 0 0.6, 1, 0 0.1, 13 here. And that's how we define our block. So we're going to use the same arrows again. We'll define the blocks this way. 1, 2, 3, 0, 1, 2, 3, and use the top, red for the top. And you can see the pattern is more or less there. Okay. And of course you can guess the last one is just like this. Okay. So anyway, first block is here. Second block. That's how the... And then what is the third block like? Same pattern. We go here. 1, 2, 3, 4. And the second set will be 1, 2, 3, 4. Straightforward. Just a bit of a learning curve, that's all. This is in cavity clipped. So this is from the cavity clipped file. So this is how we define blocks. Now let's move on to faces. Well, okay, just to verify, let's see whether this actually follows the pattern we have prescribed. So let's look for number 3. Yep, just to be sure. Number 3. Here, 0 0.6, 0 0.4, 0, perfect center. And then what's the next one? 4, 7, and 6. 4 should be here. Good. 7, 1, 1, 0. Here, a little hard to see. 7's here. Okay, 7. And then number 6, 0 0.6, 1, 0. Here. So the bottom 4, 1, 2, 3, 4. Okay, then the top 4 should be again a similar pattern. 1, 2, 3, 4. So let's check. 11, 12, 15, 14. So where's point 11? 11's here. 1, 0 0.6, 0 0.4, 0 0.1. 12 will be here. 12 here. And then 15. 15 is here. Okay. And number 14 is here. This is 14. It'll be here. So 1, 2, 1, 2, 3, 4. Okay, so I'm gonna stop now. but I hope this video was helpful in letting you know how to define blocks. Okay. So again, just to recap. Wrong file. So recap. We define the block as follows. We start at the origin, list x, y, and z. So these are flat-faced cuboidal blocks. Okay, we start at the origin, list x, y, and z. We add x, we add y, we subtract x. From the origin, we add z, we add x, we add y, we subtract x. So I'm just going to copy paste inside the description. Hopefully it will be very helpful for you. Thanks for watching. I'll see you guys next time.